In this video, we're going to look at some review exercises in equations and inequalities. Now, some of these types of problems are things you should know already, say prerequisite skills for a college algebra course that you might be taking, say maybe this fall. And it is possible that some of these you'll cover in an algebra class. But if you already know it, if you already know these concepts, it's going to be better for you. So I'm going to go through these. At any time you want to try a problem, just pause the video and try it on your own. So let's look at the first problem here. This is a first degree or linear equation. So we expect to have, if we have any real solution, this one states find all real solutions, if any, of each equation. First, we want to go ahead. One of the first things you want to do if you have a fractional equation is to clear it of fractions. So I'm going to multiply both sides by 4. So 4 times x over 4 will cancel the 4, will give me an x for the first term. And then 4 times the 2, or minus 2, will give me the minus 8 here. 4 times 4 is 16. Now we have a more basic equation. We add 8 to both sides to isolate the variable. So we add 8 here, add here. Minus 8 and 8 cancel. 8 and 8 is 24. So for the first equation, it's x equal to 24. And if you're not sure, check your answer. You always want to check if you're not sure. So put at 24 where the x is. 24 divided by 4 is 6. 6 minus 2 is 4. It checks. So when in doubt, check your solution. Okay, the next one, we got x times 1 minus x equals 6. So let's simplify the left side by multiplying through by x equals 6. So let's get everything on one side. This has an x squared here, so it's going to be a quadratic. So let's move everything to one side. Bring the minus x squared over. Doesn't matter which side. I'm going to move to the right side. Squared minus x and a plus 6. This will be 0 here. I could also write it x squared minus x plus 6 equal to 0. It's still the same equation. And then this is a quadratic. One side is 0 already, so that's ideal. We want to factor it, so we try to factor it. It doesn't factor. So then we use the quadratic formula. So the quadratic formula is x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. And of course, that's the formula used for a quadratic equation, and that has the form ax squared. A is the coefficient of the x squared term, b is the coefficient of the linear term x, and then we have a constant c equal to 0. Now here we want real solutions only. Instead of plugging everything into the equation, or the formula I should say, we look at the discriminant right here. This will determine whether we have real solutions or non-real solutions. So let's compute b squared minus 4ac. So in our case, the coefficient of the x term is minus 1. We square that, minus 1 squared. Then it's a minus 4 times a is 1, b is 6. So minus 1 squared is 1, minus, and it's 4 times 1 is 4 times 6 is 24. Now if this discriminant, this b squared minus 4ac, comes out negative, then that's the square root of negative. You could have an imaginary value there, so it's going to have a non-real solution. This is negative 23. So this one has no real solution. And it wants the real solutions only, so we don't have to do any more calculation. No real solution. Go to the next one. This one is a rational equation. Again, these are just basic problems. Again, prerequisite skills for college algebra. Even though some of these, like I said, you might learn in college algebra, it's to your advantage to already know these kind of problems. So we can put this over 1, and since we have a fraction isolated on one side and on the other side we could cross multiply, which is the same thing as multiplying both sides by 3 minus 7x. So either way we wind up with 4x minus 5 is equal 2 times 3 minus 7x. And then we go ahead and simplify this, and I skip number 3. I go back to it after I get this one, that this is going to give me then 4x minus 5 equal, then distributive property multiplied by 2. 2 times 3 gives us 6. 2 times a minus 7x is a minus 14x. And we isolate the variables. So we want the x's on one side and the numerical values on the other side. Bringing the minus 14x over, this changes the sign. So 4x, 14x, and then bring the 5 over, minus 5 comes over, you're adding 5 to both sides, so this gives me 11 here. And then 4x and the 14x is an 18x, go to 11. Isolate the x, all you have to do is multiply both sides by, or divide both sides by 18. So the 18s here cancel out, and I get x equal to 11 over 18. Okay, and back to number 3 here. We multiply through by the x here, we get x times 1 is x, and x times x is x squared, equal to 6. And then this looks again like a quadratic here. The other one didn't factor. Usually we want one side to be 0, so let's do this. Let's put x squared, just rearrange the terms. X squared plus x. Take the 6 over to the left side. Same thing as adding negative 6 to both sides. We have minus 6 equal to 0. And again, quadratics, the easiest method to solve the quadratics are the method of factoring. And if it doesn't factor, you can use the quadratic formula or the method of completing the square. This one does factor to x plus 3. X minus 2. Once you have it factored out, we know that the product of two numbers is 0. That means either one factor is 0 or they're both 0. So we simply set each factor equal to 0. Plus 3 can be 0, or x minus 2 can be 0. Then you solve each linear equation here. Add negative 3 to both sides. For the first one, x can be negative 3. For the next one, add 2 to both sides. We get x equal to 2. Or we just write it like this, x equal to negative 3, comma 2. Or we could say x equal to negative 3 or x equal to 2. Okay, clear this. Okay, the next one is that square root of 1 plus x cubed is equal to 3. Normally what we want to do when we solve an equation that has one square root and it's isolated is to square both sides. So anytime you square a square root, it eliminates the radical. So the left side simply becomes 1 plus x cubed. Square the right side, we get 3 squared is 9. Now we just isolate the variable. Add a negative 1 to both sides here, and we get x cubed is equal to 8. We have a basic cubic equation. X cubed is equal to 8 when x equal to 2. And again, that's the only real solution. There are some non-real solutions which we could get by factoring a cube. But since it's asking for the real solutions only, x equal to 2 is the only answer we get. And this one again is similar, except this is a cube root. So you have an equation with one cube root and it's isolated. We cube both sides here, eliminate the radical. So when we cube the left side, that eliminates the radical and gives me x squared minus 1. And then on the right side, 2 cubed is 8. Now we just isolate this. Add 1 to both sides. We get x squared equal to 9. And 1 to both sides. X squared equal to 9. So what number squared gives me 9? Well, 3 squared is 9. Negative 3 is also, negative 3 squared is also 9. I could have brought the 8 over and made this x squared minus 9 and then just factored into x minus 3 and x plus 3. I still would have gotten these two solutions. Okay, let's go to the next one. Okay, the next one is a fourth degree polynomial equation. This one though, factor is fairly easy. Look at that, it's a regular trinomial. One side is already 0. So anytime you have a polynomial equation and one side is 0, if you can factor the other side, you just set each factor equal to 0 and figure out the solutions to those equations. So here, like, look at this, it's a regular trinomial, and say, okay, x to the fourth can be broken down into x squared and x squared. And the factors of 4 are 2 and 2, 4 and 1, and then of course looking at the middle term, what's going to work here is 4 and 1, or 1 and 4 will work. The sign of the third term is positive, positive 4, so both signs here will be what the middle term is, which is negative. This is going to work. Because just check it out, x squared times x squared is x to the fourth, minus 1 times a minus 4 is a plus 4. Middle terms here, minus 4 and x squared, it's minus 4x squared. Outer terms, minus 1 and a minus x squared. It's a minus 1 and a minus 4x squared is minus 5x squared. So we set each factor equal to 0 here. Or better yet, just go ahead and factor these. We have difference of squares and then difference of squares. So x squared minus 4 factors into x minus 2 and x plus 2. X squared minus 1 factors into x minus 1, difference of squares again, x minus 1 and x plus 1. So now we can set each factor equal to 0. The product of 2 or more factors is 0 when 1 or all of those factors is 0. So we simply set each factor equal to 0. So you can see that here then, from the first factor, I'm going to get a 2. Second factor, I'll get a negative 2. That'll work. And then the next factor will be 1, and the last one is negative 1. So I get 4 solutions for this one. 2, negative 2, 1, negative 1. Let's clear this. This is your solution here. And that's what we expect. A fourth degree polynomial, degree 4 there. We expect at most 4 solutions. Some could be repeated, but in this case they're all distinct. And the next one, you can look at this as a radical expression also. It's a x to the 1/4. So we could just say, let's isolate that term, 3x. So 3x to the 1/4 then can be a 2. Let's isolate the variable here, so let's say x to the 1/4. We'll divide both sides by 3. We get x to the 1/4 is equal to 2/3. And this is a 1/4 power, or it's like a 4th root. So we take the 4th power of both sides and take the 4th root or 4th power of this side here, like this. And this one on the left side rather, I'm going to get x. It's this 4 times 1/4 would be 1x, or 1 exponent of 1, so x to the first. And then on the right side, it'll be 2 to the 4th will give me 16. And for the denominator, 3 to the 4th will give me 81. That's your answer for that. Number 9, you got the absolute value of 3x minus 1 is equal to 3. Absolute value of 3x minus 1 is equal to 3. Well, we know that the absolute value of a positive number is that positive number, and the absolute value of a negative number is the opposite. In other words, when we take the absolute value of any number, it's always going to be non-negative. So it will always be positive or 0, depending on what that value is. So that means that 3x minus 1 can equal to plus or minus 5. Let's look at this. The absolute value of what number equals to 5? Well, the absolute value of 5 is 5, so that's 1. And if this is negative 5, the absolute value of negative 5 is 5. So that means that 3x minus 1 can equal to 5, or 3x minus 1 can be negative 5. So here we add 1 to both sides. Here we get 3x equal to 6. This one, add 1 to both sides, we get 3x is equal to minus 5 and a minus, and a 1 is minus 4. So here we divide both sides by 3, so that means that one solution can be 6 over 3, or 2. The other one could be divided over here by 3. These cancel out, x can be negative 4/3. Those are your solutions. Again, always check if you're in doubt. The next one, you solve each inequality, express your answer using set notation or interval notation. Now, solving inequality is pretty much like solving an equation. You can add the same number to both sides, multiply both sides by a number. You just got to remember that if you multiply both sides by a negative, you have to change the direction of the inequality. So here what I'm going to do, I'm going to clear the fractions like I would do in a regular equation. Except this one's an inequality, so I'm LCD at 5 and 2 is 10, so I'm going to multiply through by 10. So when I multiply the first term here by 10, 5 into 10 goes 2, and then 2 times 2x minus 3, so that'll give me a 4x minus 6. Okay, multiplying the first fraction on the left side by 10. And then 10 times 2 is 20. And then this one, x over 2 times 10, the 2 goes into 10, 5. 5 times x is 5x. So keep the inequality less than. I did multiply by a negative, so that stays same direction. If I multiply, say, by a negative 10, I would change the direction of the inequality to greater than or equal. Okay, so then this becomes 4x. Combined terms here, minus x and 20. That's 14. Less than or equal 5x. Now, just like an equation, I want to isolate the x, so I'm going to add negative 5x to both sides here. So 4x and a minus 5x is a minus 1x, or just minus x. And then I'm going to get rid of this 14 here, so I'm going to add negative 14 to both sides, so this will be less than or equal to, and then that's going to change the sign, negative 14 over here. Okay, now remember, just like an equation, I have to isolate the variables. So this has a minus x. I want a 1x or a positive x. So I divide both sides by a negative. So when you divide both sides by a negative, that's going to change the direction of the inequality. So this will be positive x over here. But this changes to greater than or equal. So I can write the answer in set notation as set of all x such that x is greater than or equal to 14. That is your set notation or set builder notation. So that's one way to write it. And set builder notation or interval notation would be, okay, brackets, everything greater than or equal to 14. So this would be infinity over here, parentheses. So either this way, this way. If you want to solve this one, so this one can be written as, we can remove the absolute value by writing it this way. The absolute value of 3x plus 14 is less than 1/2, means that 3x plus 4 has to fall between 1/2 and minus 1/2. And this clear the fractions, I'm going to multiply through by 2, a positive 2, so I don't change the direction of the inequality. So this will be a minus 1 here, and this will be 6x multiplied by 2 plus 8 multiplied by 2. 1/2 multiplied by 2 gives me 1. And then I just isolate the x. It's fall right in the middle of these two expressions here, the -1 and the 1. So adding -8 all the way across will give me -8 and -1 is a -9, less than 6x. -8 and 8 is 0. And then -8 and 1 is a -7. Divide by 6, x then will be 6x divided by x, or 6x divided by 6 rather, gives me x, and then -7 divided by 6 is -7 over 6, and -9 divided by 6 is -9 over 6. Reduce it, this -3/2. So for these set notation, we could just write it this way: set of all x such that x falls between -3/2 and -7/6. In the interval notation, we could write it as open parentheses. If it's equals, it would be brackets, but it's open here, so it's going to be -3/2, comma, -7/6. This is interval notation. This is your set builder notation. And then the next one, solve the absolute value of 2x minus 5 is greater or equal to 9. This would mean that 3x minus 5 could be greater than or equal to 9, or 2x minus 5 less than or equal to -9. So we got 2x minus 5 greater than or equal to 9, or 2x minus 5 less than or equal to -9. So we add 5 to both two. 5 and 9 is 14, divided by 2. Both sides, x would be greater than or equal to 14. Or over here, adding 5 again to both sides, get 2x less than or equal to -4. Divide both sides by 2, we get x less than or equal to -2. And this should be 7 here. Divided by 2. So in set notation, it's a set of all x. I'm just going to abbreviate it here. And okay, it's a set of all x such that x is greater or equal to 15, or, so this is all in set notation here, or x is less than or equal to -2. So that's your set notation. In interval notation, it would look like this. So -infinity to -2, and the -2 is included, has equals, so this one would be brackets, and then it would be union, and then again greater than or equal to 7 has equals, so this would be brackets. Otherwise it would just be an open parentheses. And this would be 7. Everything larger than that, infinity. So there's your interval notation. Thanks for watching. We'll see you next time.